Hello everyone, welcome back to Math with Allison. Today we're changing it up and we're going to be doing an AP Calculus test. So this is AP Calculus AB. We're going to be doing the FRQ section. So let's go ahead and dive into it. This is for 2023, so just last year. Here we are going to go ahead and do the first part. So remember this one, a graphing calculator is required and I really suggest you use it. So let's go through the first question. So here we're given a chart. So we have T in seconds, we have F of T in gallons per second. A customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by the differential function f, where f of t is measured in gallons per second and t is measured in seconds since pumping began. Selected values of f of t are given in the table. So we're going to go down here where we're actually going to do it. We have using correct units, interpret the meaning of the integral from 60 to 135 of f of t dt in the context of the problem. So let's go ahead and do that first part. We have that the integral from 60 to 135 of f of t dt is the total amount of gallons pumped between, and that's going to be the bound, so between 60 and 135 seconds. So how did I know that? So f of t is in gallons per second, and when we integrate, we're finding the area under the curve. So if we have a curve like something like this, we're finding the area between 60 seconds and 135 seconds. So what we're doing is we're taking the height, which this is going to be up to our function, therefore this is going to be gallons per second, and we're multiplying it by the width, and the width is going to be in seconds. So here, when we have gallons per second, and we multiply by seconds, we're going to be left with just gallons, right? So when you integrate, it's like you lose a rate of change, so we lose the rate of change per second, and we're just left with gallons. And then the bounds tells us when the time is occurring, so between 60 and 135. Now we're going to use a Wright-Riemann sum with the three subintervals. They give us the three to approximate this value. So here we're using the Wright-Riemann sum, which means we're going to use the right subintervals for our function. So what we do is we take f of our right subinterval and we multiply that by the length of our subinterval. So this is going to be 90 minus 60. Plus, now we take our right subinterval and we multiply by the length of the entire subinterval, 120 minus 90, plus f of 135 multiplied by the length of that, which is 135 minus 120. So what we're doing right here is, if this is our function, we split this up into 60, 90, and that's going to be 135. So that first thing is where we're taking this height of f of 90 and we're multiplying it by the length of 30, and we're finding the area of that first rectangle. I made that a bit longer so we could see it a bit better. Now, the next one, we're going f of 120, which is going to be going up to our function, and we're multiplying it by the length of 30, and we're finding the area of this rectangle. And then finally, we have this one, which is going to be a length of 15. We're going up to a height of f of 135, and then we're multiplying it and taking the area of that rectangle. So that's what we're doing when we're taking the Wright-Riemann sum. Now all we have to do is calculate this. So over here, f of 90 is going to be 0.15. So we get 0.15 times, and that's going to be 90 minus 60, which is 30, plus f of 120, that's going to be 0.1, just looking at the chart, times 30 again. And then f of 135, that's going to be 0.05, which we're multiplying then by 15. So we're going to go ahead and go over to our handy dandy graphing calculator. This is the TI-89. And you can just go ahead and type that in, 0. And then here we get 8.25. And remember what the unit is going to be. We're approximating the area, so this is going to be gallons. And so where are the points being awarded? We can see that this question has a total of 3 points. So the first one is going to be in the interpretation. So we have the total amount of gallons pumped between 60 and 135 seconds. That's going to be 1 point, your understanding of what the integral means. The next point is going to be in the setup of the Riemann sum, so this right here. And then finally, our third point is going to be in our solution with the units. And so our third point is going to be 8.25 gallons. You lose points if you don't show your work. So you're going to lose points if you don't show the Riemann sums, right? And so that's part A. The question is asking, must there exist a value of C where 60 is less than C is less than 120, such that f prime of C is equal to 0? So recognizing this is talking about the mean value theorem, actually. So here we have the mean value theorem. I'll go ahead and write it out for us. So if f is differentiable on that interval a to b and continuous on a to b, there exists some c that's going to be between a and b such that f of b minus f of a divided by b minus a is equal to f prime of c. So let's go ahead and talk about our interval. We have that we want our function to be differentiable and we want it to be continuous. Looking back at the original problem right here, the rate of flow is modeled by a differentiable function. So since f is differentiable on this interval, that means it's also going to be continuous. This means that we can apply the mean value theorem. So let's go ahead and do that. We have f of our b, which is going to be 120, minus f of 60 divided by, and let's go ahead and do 120 minus 60. So let's go ahead and take a look at our chart to find f of 120 and f of 60. F of 120 is going to be 0.1. F of 60 is also going to be 0.1. So when we plug this in, we get 0.1 minus 0.1 divided by 60 is going to be equal to 0. So there exists some c, 60 is less than c is less than 120, where f prime of c is equal to 0. And you can say your justification, this is by the mean value theorem. So this question has 2 points. Let's go ahead and talk about where those are awarded. So the first point is going to be right here, where we do f of 120 divided by 120 minus 60 is going to be equal to 0. So this right here is going to represent our first point. The second point is going to be the answer with justification. So here there exists some value c where f prime of c is equal to 0 by the mean value theorem. And so our justification is going to be our second point. And so that's where we get our 2 points. Let's try part C. We have the rate of flow of gasoline in gallons per second can be modeled by that whole function right there, for t being between 0 and 150. Using this model, find the average rate of flow of gasoline over the time interval. So average rate is going to be equal to this. It's going to be 1 over b, which is 150, minus a, times the integral of a to b of our function. So that's going to be t divided by 500 multiplied by cosine, and that's going to be quantity t divided by 120 squared. And then don't forget that dt. So that is our average function, and we're going to go ahead and just use a calculator to figure out what that's equal to. So let's go ahead and go over to our calculator. So we're going to do an integral. So first I'm going to take that first part, which is 1 divided by 150 times, and now we're going to go to calculus. So I'm going to hit F3. I'm going to go to integrate, and now we type in our function. So that is going to be t, or I'm going to use x in this case, divided by 500. We're going to multiply by cosine, and then here we're going to plug in. So we have x divided by 120, and then that is all going to be squared. So raised to the power of 2. And then here what we do is comma our variable of integration, so that's going to be x, comma our lower bound, comma our upper bound. And then here we click enter. And if you want the exact answer, what you're going to do is you're going to go up, you're going to click that, and then you can do the green star equals. And that's going to give you your exact value. And that right there is our solution. Make sure your calculator is in radians. Make sure it is not in degrees. That is actually going to make a difference. And so this is equal to 0.09599967-ish, right? And also don't forget to write out what this means. And so don't forget to write out your unit. So when you integrate, this right here is just going to be in gallons, right? So we have in gallons, but notice the outside. What we're doing is we're dividing it by 150 seconds. So divided by seconds. So if you want to write out your official answer, what I usually do is just take from the question. So here we have the average flow rate of gasoline over 0 is less than t is less than or equal to 150 seconds is 0.0959967 gallons per second. Okay, so now let's figure out where our points are coming from. First, we have that they just want you to be able to find the average value formula. So this average value formula, that's going to give you 1 point. Now, let's see our second point where that's coming from. And that's going to be from actually getting your answer with some, justification. So we get our value, we write out what our answer is, and we write out our units and everything, and that's going to give us our second point. Okay, and now for part D, using the model G defined in part C, we're going to find G prime of 140, and we're going to interpret the meaning of your answer in the context of the problem. So let's go ahead and do this thing. I'll write out G of T right here. So remember, this is representing the rate of flow in gallons per second. So this is going to be gallons per second. We want to find G prime of 140, and we're going to go ahead and just use the calculator for that. So let's go ahead and do this on the calculator. Go to F3. We're going to go to differentiate this time, and we're going to type in our function. So again, you can use X or T or whatever you want to use. So then we do comma X, right? And then we're differentiating. What I do is I go up, I click enter, and then what I do is everywhere I see an X, I'm going to replace that with the 140, right? And then I think that's everywhere. Click enter, wiggle line enter. We get negative 0.004909. I'm just going to write that as negative 0.0049. So now we need to interpret the meaning of the answer. So we have that the rate of flow of the gasoline is decreasing. It's negative at a rate of 0.0049. Since I said it's decreasing, I no longer include that negative sign, right? It's decreasing at a rate of 0.0049 means negative 0.0049. If you put a negative right there, it would actually be incorrect. So make sure that you interpret that correctly. And this is going to be gallons. And remember, we're taking the derivative. So we're taking an extra rate of change, right? The derivative represents the rate of change. So if we have gallons per second, now we have gallons per second, or per second squared. Per second. It's like the acceleration, right? We get meters per second squared, meters per second per second. And don't forget to say the time. At t equals 140 seconds. So this one is also awarded 2 points. So let's talk about where those points are. The first point is going to be for finding the first derivative and plugging in 140, getting the correct value. And then the other one is going to be interpreting it. So the big part of that is going to be that you notice it's decreasing at a rate of 0. Blah, blah, blah. And so that's going to be where the second point is awarded. So notice what you have to do. You have to explain yourself really well. You have to be very particular. You have to include the units. So that's all part of the AP exam. Steven swims back and forth along a straight path in a 50-meter-long pool for 90 seconds. Steven's velocity is modeled by that whole function right there, where t is measured in seconds and v of t is measured in meters per second. So let's go ahead and try part A. I have it written out right here. Find all times t in the time interval 0 to 90, at which Steven changes direction. Give a reason for your answer. So think about it. Steven is going back and forth. Its velocity is going to be positive going down, negative going back. Positive going down, negative going back. What is it when he turns around? When you go from positive to negative, you hit that value 0. So what we're trying to find is where v of t is going to be equal to 0. So we set that equal to 2.38 e to the negative 0.02 t sine of pi over 56 times t. You could plug that into your calculator and click the solve button. So I'll go ahead and show you what that looks like. So this is actually going to be an algebra. So I'm going to hit F2, solve 2.38. We're setting this equal to 0, and we do comma with the variable that we're solving for, which is going to be x. Click enter. So we get 56, and that's going to be plus pi n, that little at weird thingy. That's going to be, because it's sine, you know how it oscillates. It's going to be at every like pi interval. So let's go ahead and solve for that just using this. We can divide by 2.38, so we get 0 is equal to e to the negative 0.02 t. We have that e raised to something is never going to be equal to 0. No matter what t value you plug in, you're never going to get an output of 0. So all we have to worry about is the sine portion. Taking inverse sine of both sides, inverse sine of 0 is equal to pi over 56 times t. And when is sine equal to 0? Well, that's going to be at 0. That's going to be at pi, 2 pi, 3 pi, so on and so forth, right? And that's equal to pi over 56t. Dividing everything by pi, we get 0, 1, 2, 3, so on and so forth, and that's going to be equal to 1 over 56t. So I'm going to multiply everything by 56. We get 0, 56, 112, and I'm not going to even include the other ones, is equal to t. So now what we need to do is consider our time interval. It's going to be between 0 and 90, and the only time that occurs is at 56. And so we found the times where Stephen changes directions, and we need to give a reason. So Stephen changes directions at t is equal to 56 seconds because his velocity changes signs, right? That's going to be where the velocity he's turning around, so it's going from positive to negative, right? So let's go ahead and talk about where the points are awarded. So the first point is going to be where you consider v of t equal to 0 and you solve it down for t is equal to 56. You're not going to get a point for just writing t is equal to 56. You actually have to show your work. So it's going to be knowing that you're setting velocity equal to 0 and you're going and solving it. The other point is understanding what's happening right here. So yes, you got 56 seconds, but why is that where he's turning around? And that's because his velocity changes signs at that point. So that's where the second point is going to be awarded, is for the reasoning. Let's go on to try part B. Find Stephen's acceleration at 60 seconds. Show the setup for your calculations, indicate the units of measure, and the question is Stephen speeding up or slowing down at that time? And you need to give a reason. So what we need to do is we need to differentiate the velocity in order to get acceleration. And then what we need to do is plug in our value. So the value we're plugging in is 60. That's going to be the acceleration at 60. So let's go over to our handy dandy calculator, clear that. We're going to go ahead and differentiate. So we're going to go to calculus, differentiate, and we're going to type in our entire function. So 2.38. And then we're going to do comma x because we're differentiating in terms of x. So now that I found the derivative, I click up, enter, and everywhere I see an x, I'm going to replace it with that value of 60. Okay, and then I click enter. Ooh, right there, negative 0.036016. So we get the acceleration at 60 is equal to negative 0.036016. And remember, you need to show your units, so that's going to be meters per second squared, right? We show the setup, right? V prime of 60 is equal to a of 60. We showed our units of measure. Now, is Stephen speeding up or slowing down? Just because it has a negative acceleration doesn't mean it's slowing it down. What if he's going in the negative direction? A negative acceleration in the negative direction means actually he's speeding up. A positive acceleration in the positive direction, so positive velocity, means he's speeding up. Now, if they were opposite signs, that would mean he's slowing down. So if he's going in the positive direction, but his acceleration is negative, slowing down. If he's going in the negative direction, but his acceleration is positive, he's slowing down. So actually, we need to go ahead and find v of 60. So let's go ahead and type that into our handy dandy calculator. So here we get 2, enter, negative 0.1595. So since the acceleration and velocity are both negative, and I'll write this out, Stephen is speeding up at t equals 60 seconds. So let's go and talk about where the points are awarded. The first point is just going to be the setup, and actually it's literally just this right here. If you can show that the derivative of velocity is acceleration, great. The second point is going to be the solution with the correct units. Remember, units are very important on this exam. And then the last point is going to be the speeding up. So we know he's speeding up with the reason, and that's because both of these are less than 0. You found that they're the same direction, therefore speeding up. So that one's a total of 3 points. Let's try part C. We have find the distance between Stephen's position at 20 seconds and his position at 80 seconds. So in order to find the distance between those two positions, we're not doing the total distance he's traveled. We're just doing the distance between the 2 points. This is just going to be the integral from 20 to 80 of our velocity function. We're going to do total distance in the next problem, so don't worry about it. So this is just going to be the distance between those 2 points. Let's go ahead and integrate. I'm going to show you how to do this on the calculator. So here, I don't know why it does weird things in between. So here, let's go to integrate. We're going to type in our function. I'm sure you're tired of typing it in. I know some people know how to store it. Whatever you can do to save time is probably going to be the best. I can probably learn to store it, but I didn't. But I still pass these exams, guys. comma our lower bound, which is 20, comma our upper bound, which is 80, enter. 23.384. And this is just going to be meters. And what I do is I take from the question. So the total distance between Steven's position, I literally just take from the question and I rewrite it and then I answer it. This way there's like less confusion on what you're answering. There we go. So here, where the points are awarded, this is going to be 2 points, obviously. The first one is going to be just setting up the integral. You don't even need to put in the function. You can just write b a t. That's going to get you the point. So that's going to be the first point. And the second point is going to be the answer with the little, like, nice little sentence. Now let's go ahead and talk about the last part. We have find the total distance Steven swims over the time interval 0 to 90 seconds. Find the, show the setup for your calculation. So this is going to be total distance, which is going to be a little different. So we have that the total distance is equal to the integral of our bounds, it's going to be 0 to 90, of the absolute value of our velocity dt. And so remember in the first part we found where he changed the directions, and that's going to be at 56 seconds. So we have 0 to 56, that's where he's going in the positive direction. And then we have minus 56 to 90 plus the negative, because he's going in a negative direction, plus negative becomes a minus, and that's going to be v of t dt. And of course, you can just go ahead and plug that into your calculator. I'm going to go up, I'm going to click enter, and I'm going to change the bound. So our first one is going to be from 0 to 56, minus, I'm going to go up, I'm going to click enter, I'm going to change the bounds again. So this one, the lower bound's 56, and then the upper bound is going to be 90. And then I click enter. Busy. Okay, 62.1642. 62.1642, and that's going to be meters, right? So here we get the total distance, and I'm again just taking this straight from the question, over 0 is less than or equal to t less than or equal to 90 seconds, 62.1642 meters. So this one's also 2 points. Let's go and talk about where those points come from. First, it's understanding how we can set up the total distance. So this right here is awarded the first point. The second point is getting the actual answer with the units. So for this one, you miss the first point if you don't set up those integrals. You do get awarded only 1 point if you do have the solution there, but you're missing 1 point, so that's kind of sad. So that's the end of part A. That's the end of the calculator section. I'll make another video on the second part of this exam where there's no calculators required. But that's all I have for us today. If you enjoyed this video, I have many more like it, so make sure to check out my playlist or link down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.